say in range, right? You can start from 1. Yeah. So you can, maybe if you say 1, yeah, if you don't say 1, it's going to start from 0, then we will be in trouble for the division. If you say 1, it will start from 1. Will this include the number itself?
No.
How to include number itself? Plus 1, actually. If you say plus 1, okay, if you don't say plus 1, it will go until number minus 1. It won't include the number. If I want to include it, I will say this one plus 1, so it includes the number itself. Yes?
Do you need to include the number itself? Because the number is always divisible.
Yeah. But I want to include that in the list, right? In the divisors list. Because by definition, right? See the blackboard? If you have 6, well, the 6 should be in the divisors list. Because the numbers always should be in their own divisors list.
Okay.
Yeah, well, that is, yeah. I mean, you could do it out of the loop, but I can just now here do it inside the loop. It's obvious that it's divisible, but it has to be in that list still, if you want to be 100% correct. So everybody follows what's here, going on here? Okay. What should I say next? Yes? Yeah. But we haven't done any if statement.
Sorry.
If
Number module I
yeah,
is equal to 0.
then we can add it, yeah. Append, or even we can, append is a good idea, you can do it. Or you can just say plus equal. Yeah, thanks for the append, but I think the simpler thing is this one, right? You just, now we are adding I to the end of the list. Seems many people like append, so we'll type append I. Okay? So this I is one of those numbers, so if that is divisible by the number, so we just now add it to the list. Then we should add it like this, right? No? We don't have to? Okay. Because I've almost never use append, I always use this. The basic way of doing it. Okay. Is this now done? Yes.
If I use plus equal sign, do I have to put the square brackets around?
Yes. Yeah. Is this function done? Yes. You have to return that thing. Okay. So let's test it, right? So let's test it. Although it's going to be called from this function, other functions, but I'm going to test it anyways. Let's test it for 6 and then print it, okay? Yes? We can do, yeah, you're right, yeah, you are right, yeah. Thank you for mentioning that, because yeah, then the else will get us in trouble, yeah. Thank you, yes, that's the correct way to do it, yeah. Yes?
What if you put the unit on top before the for loop, and then return it after the else statement?
Sorry, can you say it again?
Like you divide this before the if statement. You get the top.
It could be there, but yeah, but I mean, for error condition, well, if I say, well, I could say return here or not say it, but if you just say empty error return, it will return with nothing, with none, because that's my imagination, right? I'm going to say that if some error occurs like this, and I don't want to return anything, then in that case, you would return a list that has nothing in it. That would be two different things.
No, I mean, just put like the divide this before the, like on top of the formula, before
Yeah.
the if statement. Doesn't make a difference.
The difference will be very tiny. I'm not saying that is incorrect. I'm just saying that See, we have to agree and discuss what should I return if error occurs, right? Because what you are saying is going to impact that error condition. Yeah, I mean, see, it's about, see, I could do it here. Now you can have the return at the end or here, right? So it's about when this error condition happens, what do I need to return? My imagination is that I shouldn't return anything. So anything means just error none, return none, right? You know, none. So, okay. If I test this function now, okay, these functions are not defined, so it's going to get upset. I'll comment them out. Okay, so this one for 6, for 60 you can test it. I think this is pretty much correct for 60. Let's go now to the invalid conditions, to negative. Yes, input should be a whole positive number, and well, none is that I'm going to get a none from that. You can try to get 6.2 non-integer, so it's going to again give you that value. So you're going to see you can get a -6. All right, so you see that it works as we expect. I hope I'm not going too far, because some people may seem to be quite surprised. Do we need to look at it again and discuss it again, you think? Should I explain anything again? Please feel free to say that and we can look at it again. Yes?
Say again where you run into trouble with the return device list.
Yeah, I think, see, I think, well, now it's okay. I mean, you could have this thing here, right? You could have it here if you wanted to. Now, this device is afterwards. Now, if I have error condition, it will return this thing, which it will be empty list. Now, in this case, it will return empty list for error condition. It's okay from some view, but I would prefer to return nothing, because empty list is not the same as nothing. That's a list still. So it's just, yeah, about how we interpret and decide what to return in error conditions. Any other questions? Okay. So, okay, let's go to the second question, second function. Is it a perfect number? A perfect number. So how should I do it here? Yes. Yeah. Good job. Yeah. Okay, I'm going to call it and pass the number. Name the variable. I can call it, well, I can call it divisors list equals get divisors list. That's a nice way. Divisors list equals get divisors list. You get it and you store it, okay? How do you do that? Yeah. By the way, we have a sum function. Even you can use. There is a sum function. You can pass a list, it will give you a sum like a magic. Yeah. Yeah. You can do it with for loop, or there's a built-in function. Okay? So I can put an if statement. How do I say the if statement? You have the example in the blackboard, right? So I have to sum it up, and if that sum is equal to twice of the number, then it is a prime or perfect number. How do you, yes, do you want to say that? So if the sum of divisors list equals number times 2, right? Because for 6 it's gonna return 1, 2, 3, 6, so the summation will be twice of it. Because we have the number itself now in the list. So again, let's not confuse that. We have the number itself inside it. So the summation should be twice of it. What should this function return? No, actually, well, so it's a question, right? Is it a perfect number? So the question, well, on the blackboard, what do we have for the output? Yes, exactly. So true and false. So this function should only return true and false. The second function, because we already did some design, right? And on the board we did some what should return. In this case, return true. And what should I return false? How should I return false? Yes, else return false. Essentially, I'm saying sum up those divisors list that you get. If that is a number times 2, then you have found what you are looking for. Else that number is not a. By the way, even the PDF file was saying that. I know it's too much for us to remember. Checks whether a given number is a perfect number. It's going to check whether it is. Even here, I'll discuss that. I'm going to check it. I'm going to return true or false. If for 6, it should return true. For 7, for example, return false. And we have used the first function though. So as we were thinking, we are making call. So this is the function called to the first function. Any questions? We can test it again. Is it a perfect number 6? Or is 6 a perfect number? Right? So we wrote it almost like English now. Number 6. So true, right? So he said yes. So true means yes, right? Let's check 61. 61 is not. Let's check 7. Let's check 9. Let's check 21. Let's check 13. False. So all of them false. And what was the other perfect number? 48? 28, yeah. Let's check for 28, the last one. True. So this function works properly, apparently. See? You can keep calling it and pass different numbers. All right. I'm going to hide these things. Code comment with line comment. So they're not comment. All right. So that was the test that I did. You can put here pass. All of them passed for us. Print perfect numbers up to. Okay. So this last function should now make use of this second function, right? So you just function 2 makes use of function 1, and number 3 makes use of number 2. Okay. How should I write the last function? Yes. Yeah. Good idea. How to say the loop? For I? Thank you, yeah. So, exactly. So what our friend is saying that, well, this loop will go from 0 to that. Perhaps I can start from 1, right? Because, well, 1 for sure is not a perfect number, and we don't want to even, this is 0, we don't want even to look at it. Okay? Yeah. But we even, okay, let's also, by the way, check. So it should say that Let me just check to see if 0 actually is not a, I was just picky. I just want to check if 0, see for 0 actually to turn true. That's a bit weird, right?
We have, I think, check it.
Yeah. Equal to. So we have to remove the equal to 0. Because 0 even doesn't have divisors. Oops. Now it got so crazy, so upset. Well, you see, it gave the error message, but then it crashed in the other place. You know what happened? This thing gave the error message, so that function actually rejected it. By the way, you know the exit function, right? Well, I suggest we exit here from the program. You know, that's easier, right? There we go. You don't have to think about when it comes back to the other functions, what should I do? So you know the exit, so if you call with 0, I will just exit. That's, I think, better scenario. Okay, so that was the 0 case. I want to ensure that we are doing it properly there. Okay, there are always little holes that we need to look at to test. Okay, so back to this loop. Yes, open, yeah. Yes. And yes. This function, is it a perfect number with for I? And then what do I do? Yeah, if statement. Even we can leave this, you know that we can leave the true out because, yeah, okay, but we can do it like this. Then, list, or we just print it, right? Because this function just has to print. This function can just print I. So the algorithm is that I go from 1. So I have this loop, I goes from 1 to upper limit plus 1. So range will return me each of those values. If this limit is like, let's say 1,000, it's going to go from 1 to 1,000, right? Not 1,001. Because range will go to 999 and then plus 1 will be 1,000. If a statement will check, we'll call that other function and check if it is a perfect number. If yes, I print it. Do I need an else statement? No, because if it's not, I don't print it. So I think now we are all waiting to see if this function works properly. I ran it. 6, 28, and 696. Is that correct, right? Perfect numbers. 4, 28, 1, yeah. And then the next one is 8,128. Let's check for that. I put 10,000. You see, it took some time, and then it found it. It's getting some time because it has to, and so the runtime, so it's the performance in terms of the execution time, because it has to call the first function, and that gets a lot of time to get divisors and put them in the list. That's a lot of operation. Yes.
The exit function. Why did you put in 1?
1 is the error code. You know, the exit code. So 0 means it exits the program successfully. Usually, see when your program finishes. Well, process means an execution of a program. 0 actually means success. So it's a kind of counterintuitive. 1 means some error occurred. I mean, I can put here 1. It would be the same, but from the outsider view, then he will see if some error occurred or if it was healthy finish. Yeah. Yes, so we run it, you see, it works. We can go to 100,000, but then it's going to be slow. You want to see that? Yes. Well, we can see that, but we actually run it. So you're going to wait. It's going to take several minutes here. See, the program hasn't finished, see? Until you see here program finished, it's going to run. Actually, I'm going to stop it. I want to show you. I'm going to put a print statement here, I, calling analyzing I. Now you can see how it analyzes it. See, analyzing 6,000, 7,000, 400,000. So you can see, you can track. And some of them, of course, going to print if it is perfect. So now you see it's slow, actually. Well, because it takes lots of CPU to do the analysis. It's going to keep like that under 100,000. So it's nice, actually. Yeah, it's going to take. When you can look at the CPU, see, Python is consuming about 13%. Actually, and the reason is that there are about 8 CPUs, right? There's 8 cores, so you have 8 CPUs on each on this machine. You see here, there's 8 CPU. Actually, one of them is overloaded. Well, the task is given to that CPU. The other ones are almost resting. They don't have too much task. Yes.
Why is that? Because it seems like a relatively simple computation.
Because this function, most of the time is spent in this function. Because division actually, when you do it once, it's fast, but in terms of milliseconds, it takes more milliseconds than others. And because you are doing it many, many times. For each number, you are going from 1 to that number. So if you have 53,000, you are going from 1 to 53,000, and you are dividing each of them. So there's a huge number of computations involved. Do you want to show you how many times the loop runs? I can show you, but it's going to give lots. Int number of runs 0. Not int. I hope I have that. I haven't done this in Python, but I'm going to do something crazy. But let's see. Okay. Let's see if we can count it. Yeah. For assignment.
It's not part of the return anyway.
But I put it outside.
Maybe before the for loop.
You know what I was.
Maybe add it to the return in that function to also return the number of runs. Because that's inside before loop, so it's not.
But I want to keep. Okay.
It's got
Anyways,
a
it's.
variable inside.
Yeah, the global variable didn't work. But I want to keep it. I don't want to make it 0. I want to just keep adding to it. So. The global variables, yeah. I'm not 100% good with global variables here. Yep. You have to look it up. I mean, in Python, don't we have global variables? Like using global variables in a function. See, global variables. So you can do like this. Oh, okay. We have to check global. Okay. So we have to say this global thing. So you put a variable, and then inside it you can. So you have to say the word global. Global number of runs. Okay. Now, there we go. You see this number? Number of runs. So that grows very quickly. It's not analyzing only the number 12,000, and this has run. The loop has run for 72 million times. This is the loop. This is the loop that checks for divisors. I was going to show you that. If you run it, that's going to grow like, yeah. You see how quickly it grows? 27, 30 million, 40 million, 53, 50, 60. It grows exponential. It's not as more than 120 million, you see? Because, yeah. that is the number I was checking for perfectness. Now that is 166 million. So the loop that runs inside the divisors. Okay, I don't want to frighten you, but with this you can analyze how complex our functions can be. And we don't see it when we run it, but behind the scene, that divisor's function is called those many times. Yeah. Because that loop, again, as I mentioned, you give a number and it checks, it comes from beginning to that number. So you keep adding all those, so it's lots of operation. Yeah. Okay. Yeah, this was something advanced, but now you can see that I have a variable. I call it global. Global means it's defined outside the function. And then I can now use it from inside the function. You can remove it. So it could be quite confusing to later see that, but I just wanted to. Yeah, it's interesting to. All right. Can now run for 1,000. Okay. All right. So this program finished, and I think I'm just going to leave it for you to have a look at it. And if there are any questions, think about it. Make sure we understand every detail of it. And if there's yes. Can you say it louder, please? If I put integer number? Negative. So let's put, negative number. It could be that the error checking has to be done further. So let's see. Okay, do you know what's the reason for this? It doesn't say any message? No, actually. The reason actually is here. The reason is inside that range. Now, can you guess what is the reason? For -2, it doesn't say anything. Because you pass -2, it comes here, upper limit becomes -1, and the range will not do anything. So it just exits. It doesn't even give an error message. So you may want to put your error, your error checks here again. I can leave that for you to be done. So because that is the entry point. This is the entry to all the functions, and it doesn't. But we do the error checking and that function, not here. Yeah. I mean, you can bring the error checks later as well. Because from main, I call this, and it gets stopped here if you go to negative values. And range will not complain if you give it negative values. It will just not return anything for you. So the for loop will not run actually if you have a negative value. Any other questions? Perhaps we all need some more time to think about it. Please, so many of you have in laptops, you're typing it. Please think about it, or write it on paper, discuss it with your friends. Make sure we know what every line is doing. Okay, seems there's no question. So we'll take about 15 minutes break, come back at 5:50.
Are you the least of the previous group?
Sorry?
I'm in the previous group.
4, there we go.
Yeah, D, group D.
4.
Yeah,
Here
four,
their
yeah,
names.
four.
Yeah, just have a look at it and yeah. Sayın Çağatay arkadaşım, teşekkürler arkadaşım, sağ olun. Hatice hanımın ellerine sağlık. Ben de şimdi dersten bir havaya çıktık, bir 10 dakikalık. Çay içip tekrar döneceğim. Bir 5 saat evet bugün ders. Sana da kolay gelsin Ubuntu kurmakta. Öyle tabii işler bazısı böyle çok sürüyor. Teşekkür ederiz tekrar. İnşallah heyecanla inşallah bekliyoruz. Siz de akşam görüşürüz. Baş üstünde biraz az yeriz yemeğimiz evde. Geliriz sizin yanınıza. Teşekkürler. Yes, yes.
Your microphone is on.
Sorry?
Your microphone is on.
Oh, okay. You're right. Yeah, please have a look at this, and I think, yeah, read it, and then we will do it together. So actually the main part is in the top, so this after defining thing you can read it later. Okay, perhaps we can start it. Has anybody made some progress? Yes? No? I feel that only a few people are working on it. Okay, so let's start here. So what do you know about classes? Let me first ask this. What did you learn this week about them? Okay. Can somebody explain that? What you learned so far? You want to say? Okay, yes?
They are user-defined structure type.
Yeah?
They can take values and we can define methods for classes and operations. And when you create a class, the name should be commented.
Yeah, those kind of things. And what examples did you work with? I know, but like what type of, like, did you work on an employee class? What type example class names like did you define during? You have in the assignment. It's in assignments, right?
Oh no, it
Homework?
was lecture last week.
Next to last, okay. Okay. So, actually I was, showing it, where was it? Object-oriented programming. Yes. Right? Let's see this car. It looks like a car. So class is a part of something called object-oriented programming. So you can write objects. So you program in a way that you work with objects. And I will tell you what. Do you know the difference between a class and object? Did you learn that in the class? Okay. So let's see what's the class. So as our friend said, class is something, is a structure, the user-defined structure that has methods. So method means functions, has functions and variables. Variables or attributes. For example, for a car, you say, well, a car has fuel, max speed, just two are written here. Like a car has a model, color, production year, number of cylinders, all the things that it has, all the properties. And some behavior, right? So what is a function? Function allows the computer or our program to behave, to do something. For example, a car has refuel, right? Like you can refuel a car, you can get the amount of its fuel, you can drive it, you can set speed, get the speed, this type of things. So a class is the essentially component of all this. So class will own functions and will own variables. So we want to define that. For our exercise, we have, we're going to let's call it money pouch. Pouch, right? Like a basket. So so we're going to say class money pouch. In parentheses, we can say few things. Let me just say object for now. You could say other things, but let's leave those because those could go to advanced topic, and I suggest we leave it out for now. So let's just say we can just write an object here that has a meaning, but we just didn't write an object there. That's the basic. That's the primary, the basic version that we can work with. Now I can define some object functions here. For example, I think you heard about the init function, right? Last week, yeah. What does the init function do for a class? Initialize value, exactly. Also, we call it constructor function. You can call it initializer or initiator, or better name is constructor. That's the more established name. So construction function, Python. So yeah, Python constructor. So people keep talking about these things. Okay, constructors. Okay, so it initializes. So what variable do I need for this class? Amount of money, exactly. It says the class just needs one data item. But data item means what it should store inside itself. So I will say amount. When we say self, this self has a meaning. It means the current class. And I think now, I think I asked this question. Let me ask it again. Do you know the difference between object and a class? No? Yes, I think.
Class is something that makes the object. Object is just like if object is a car, then class is the factory that makes it.
Okay. You are very close. So thank you for the attempt. Very close, but I will make it more precise. Let's look at the integer, right? So let's go back. This makes this noise. Integers. When you say I equal to 2, j equal to 5 or 51, so integer is a type. I and j are variables. Okay? Type and variables. Here as well, you can say a car. That's my type. It's a user-defined type. I can define class. So now I said money pouch. I could say car, class car, color, everything. And then we're gonna say, for example, C equals big car, like in parentheses. In Python, we will like this. For example, for money pouch, we will say MP or M or whatever name equals money pouch. So now, this C is an object, or that MP there will be an object. Object is the same as variable. Is a variable. So object is a variable. Class is a type. Just like that. It's so easy. You don't have to make it complicated. So, as it's just like we say, I have I and j, which are variables of type int. Here you say C is a variable of type car. So class is a type. So you are defining your own types. You are saying integer is a good type, but I have a specific needs. It's not enough for me. So I define my own type, which I name car, or I name money pouch, or I name anything else. So here actually, you see, create an object named MP of type class money pouch. Okay, define. So we can define objects like that. This was like this. Okay. When you say self refers to the current object. What's the current object? Our friend was saying something about how a factory builds classes. So really the factory, here the factory actually is Python. You say, I have this class and I need an object of it. You say MP equals that class, so it gives you, it manufactures this object for you. And then MP becomes an object of this type, and then self will refer to that object. So if you are inside that object, you will refer to that object that you are inside. So you're going to see this self a lot. We say this self, so it's a way to connect. You are saying, well, this function node belongs to this class. So you are making that connection. You are gluing it. And we only use it in the object-oriented and class programming, not in the regular programming. By the way, the regular programming that we were doing up to now, which is like this, not this, but we wrote just half an hour ago, we call this functional programming. Everything's a function, there's no class, so functional programming and then object-oriented programming. That's the style of programming. Here also we have to say self so that we connect it to that. If you create a new account, how much will be the amount in it? 0, right? Yeah, so we put 0. It finishes the first function. So we need one variable, we just put one variable. If you need more variables, you can put, say, variable number 2. You can define more variables if you want. Okay. I need 4 functions. Show balance, add some money, remove amount, check if I have some required money inside. So we write them in order. Def show balance, let's call it. See, if I press parentheses, it just puts self itself. It's intelligent, it knows that I'm writing class, so it just writes. So see it again automatically. So how do I check the balance? Do I need a parameter to check the balance? Show the current amount of money. So how should I show the current amount of money? Yeah. So, well, again, note that we won't print anything, we'll just return them, right? So just say return. How should I return that amount? Exactly, save that amount. Just like that. Because now this amount is a variable of the class. Every function can access it. So from here you can access that because it's, so don't forget this picture. Where was it? Yeah, don't forget this car picture. Everything is inside the box. You have functions and variables inside that car box or the class box, and everything can access everything until you are here. Okay. The other function is add. We need add. I need remove. Okay, just write them. Okay. For add, it means adding some money to this account. What parentheses do I need? What parameter do I need? Sorry? Yes, amount to add, you can call it. That's a nice name. And how do I add it to the amount? How do I add it to my current amount? Exactly. Yeah, as easy as that. It doesn't have to be complex. Of course, we need to do some checks because if you say add negative 10 euros, it becomes invalid. But let's write the basic version and then we come back and add those checks. Remove. What parameter do I need? Exactly. So it's the vice versa of, see, I like copy and paste. And how should I remove it? Exactly. And go here, put minus, put this one. There we go. That's the remove. I have one more function. Check if required amount of money is available. And I should return true or false. So def check money available. What parameter do I need? Yeah. Amount required. And how do I check if I have that or not?
Check if self.amount is larger than 0 and then it has been released.
Greater than 0?
Or it's just larger than.
Amount required. And what should I put in the beginning? Yeah. If this is greater or also equal, right? Because if I have the same amount, then I have it. If you have 2 euros and if you want 2 euros, then you have it. What should I do? Thank you. Else? Yeah. This function is done too. See? Now the bare bone of this is done. It's almost this much. That's the bare bone of the class, believe it or not. Now we need to add, like I can add, if amount is not positive, then complain, then do this complaint. So we always hope user doesn't give invalid inputs, but unfortunately users give any type of input. So usually that code actually becomes even more than the bare bone, often. So we can test what we have so far without those additional stuff. Let me call it, I can call this account 1. Let me call it account 1. You can call this any name. Account 1 equal money pound. Even I can create account 2. So now each of them will be different variables. This is just like you are saying I equal to 1 and j equal to 2. This is almost like that, almost. So you have these are variables, these are also variables. But here you are saying create an object for me and give it to me and store it here, and then create an object and give it to me. Now, you can say account 1, let's say get balance. What do we have for balance? Show balance. Let's call this get balance, right? Because it doesn't show them, because show means print. It just, you want to get it and then print it yourself, right? Everybody's following? Get balance. And so if you print this, how much do you think the person has now? 0, right? So yeah, 0. Do we want to add the beautiful euro sign? You know, I got that euro sign. It was hard to type it on the keyboard, so just copy paste from here. I steal it from the internet. I can put it here, for example. Euro sign. Oops. Okay, I have to convert this to str. Yeah. So 0 euros. Now you're going to see the euro sign, which is nice. We see some money we're talking about. So I just do it there so I can get the value, the concatenation. Okay. Now let's put some money, right? So it's going to get more interesting when you put some money inside. Account 1 dot add how much money? You want that 15 euros? Okay. Then you print it again. First it has 0, then you put 15, which is fine. You can add more. Let's add 220. You're going to get more, okay? So now we get some, now we're going to take some money out. Remove. How much? Okay, let's remove 210. How much do you expect now? It's quite hard, right? 210 minus this will be 25. There you go. Okay, now I'm going to get more money, okay? Now you have 25 left. I'm going to get 60 out. Well, it's going to go to negative. Well, we don't want this to happen. Right? But you know that some banks actually allow to a certain negative amount. They give you credit. You can go to that. But so let's not allow to go to negative. Okay. What should I do in remove? What should I do here?
If self amount bigger than amount.
Great. Even you can call this function, right? Because that is actually here. We have a function called check money available, right? That's more chic way of, or elegant way of doing it. You can say if amount greater than amount to remove, but also you can just use this function. Check money available. Seems people don't, like to use that, but let's just say, this one. Everybody's following? On the left side, I want you guys to follow, more closely or give ideas, So what should I write here?
Bigger than.
Bigger than?
Or equal.
Okay, or equal. Then I can remove. Yeah, else, what should I do? Yeah, I can print and say, error, not enough money. And we can say, well, the error function said that. Error in error remove function, not enough money. And I can perhaps exit the program. That's a bit too harsh, but let's just exit it so that the user can now make up his mind, right, what to do. You know exit function, right? That will exit the program entirely. You can put 0 or 1, and 0 means success usually. 1 or other code means error actually. But it doesn't matter what you put inside. It's going to exit anyways. So so it's going to get that money. So at that point, it's going to stop. So even if you have more code after that, it's not going to get to them, right? So there's not enough money. Okay? Everybody's following? Just, I hope I didn't go too quickly, but so what we did was to write several functions inside this class to make sure that it adds some money. You can remove some money. You can, what else? Show the balance. You can check if money is available. And believe it or not, this is like almost like a simple ATM machine. So now you're building something that you can, you go to these machines, you get money, or you go to stores, you spend. So some code like this is written behind and actually is executed when you do it. So we are writing something very simple, and if you work on this for several weeks, it's going to be like a real ATM machine. It could be. So if you take one of our advanced courses, the students spend several weeks to actually build an ATM simulator. Very similar. You just have it. Well, you don't have the hardware, but you say one, it does everything. It checks. You can transfer money, so you can do everything. All right. Yes. Sorry, empty. Which one? Exit. So 0 means, okay, let's answer you, right? So remember, if your program finishes successfully, if you have no problem, program will finish with exit code 0. And well, I didn't exit, right? So the program itself, when it finishes properly, normally, you get error code 0. So 0 means success in exit. If you have, so 0 equals success, anything else, we call them error code. Error code, it means as failed, failure. Yeah. So 1 means one type of error, yeah. So, but in this course, we don't differentiate between them. If you want to write advanced programs, then there's difference. But exit, it will, if you write exit, it will exit the program without asking any question. Yes?
Why do you exit? Because I don't see it. I think it's said in the exercise. It just says saying raise an exception.
Have you learned the exceptions? Have we learned? Okay. Because yeah, this week term, I guess, period. Yeah, Mark removed that from the course for yeah. So that's why we are not going to go to the exception discussion. Yeah, that's another type of dealing with problems. He decided, yeah, I forgot. I don't know why he decided to remove that, but we don't have it. So we just print a statement and exit program. That's very simple, right? You say, well, there was an error, so I exit. So this was account 1, right? So you can do the same thing with account 2. Now account 2 has, see, now all these things that you printed are for account 1. So each of these objects will have different value inside themselves. Well, now if I now print, it's going to be a bit, okay, we can print like this. How to say? Okay. What I want to show you is that so each of these variables have an amount inside them, and you can work with them separately. So each object has its own independence. Like you have account 1. Actually, literally in your memory is like this. Account 1 and has amount. I mean, you put 0 and then you make it, you put 15 and then you put 220 becomes 235, right? You keep changing it. And account 2, so each object has its own amount and they are separate. This is 235 and this is 0, for example. I just want to highlight this. Different objects of the same class, they are staying in different places. They have their own. Here, each of them only has one amount value, but they could have many other values as well, if we wanted to add them. And I can show you how it works. For example, this is like what we print for account 1, right? These are some activities that I defined on account 1. You can define some activities on account 2. So for example, for account 2, right, for account 1, we did put some money, you know, we did this, we did that. And for account 2, well, it has nothing inside. So now you can keep doing, or you can even do like that. Like you can say, you know, you can do lots of things. You can say, well, remove, let's say, for example, 10 from account 1 and put that to account 2. You see? And now account 2 has to change. I hope account 1 has 25, so you can take 10 out of it. And then add it to 2, and then show the balance of 2. Okay, something happened. Okay, yeah, okay, yeah. When we do remove, yeah, we don't have to print something, so this don't have print, okay. I just want to say that each variable, each object has its own lifetime, they call it. You can, I mean, they have separate, so that amount variable now you have 2 times, 2 places. Okay, so yeah, so that's an example of how to work with classes. And as I said, money pouch is the name of the class, this is the name of the variable or object. Object is a variable, so no difference. But it's a more complicated variable, right? So, yeah. So I guess I need now to give you some time to look at this and digest it, make sure we all know how we wrote this class and how we used it, because you define it and then you use it. So we have to be comfortable in both ways. Yes?
I tried to use the check money available in the remove like method, only it doesn't recognize it.
Let's see. Did you say self? Think, yeah, you should say self there as well. So whenever we refer to any variable or function, so I can try to write it like that. Alternative. So you have to say if self check money available amount to remove, then we can do that. Because it's not a regular function, it's a function inside the class. So we have to say we are referring to the function inside the class. Now let's see. Yeah, it works this time. So yeah, we just have to say the self in front of it. So this is, you know, this is the same as that, right? So we have this elegant way of doing that because we have the same code there. Now we are saying, if check money available, do I have this much to remove? If yes, then I remove. If not, I cannot remove. Yes?
And the class function with the constructor, why did we have the second variable?
Okay, I just defined it like for no usage. It was just for the sake of defining it. I just want to say, yeah, you can define more variables if you want. This has no usage. You can remove it. Yeah. You can define more variables if you want. Yeah. Any other questions? Yeah? No, you don't need to have if. So you don't have to use each of these variables everywhere if you don't need to. is by what you need, you do it by your need. So see, I'm using amount everywhere because this amount is the central focal point of this function. Define the init function. Yeah. You mean init function or this function? Get balance? Remove? Okay. This self keyword should appear in all the functions, yes. So as a parameter, well, it's not really a parameter, but we use this, we put the word self here to clearly say to Python that this function is a part of this class. So we are gluing it, we're saying we glue it together. Like, again, don't forget, yeah, just like this. So it puts it inside the class. So it's gonna draw something for us and it's gonna put them inside. That's, so this self, we have to say it. And then the other parameters that I actually need in this function. For example, get balance actually has no parameter. I mean, because this is like, they call it implicit parameter. I mean, it's a parameter of self and you don't use it. I mean, so because where you use it, right, you say get balance and nothing, right? So here you don't see that, you don't say self here. When you call it, you don't say self. And for other functions, for add, right? Well, for add, you have to say how much you want to add. And this is how much you want to add. So that is the parameter you are going to pass from outside. Okay? Yeah, makes sense.
So in this function, we are not using variables to just an example, right?
This, yeah, no, I'm not using this, so just you can hide it. Yeah. So what you need, you define, right? So it's about your need. So all the programming is like this. You say, I need this variable, I need that function, so you just define it and as you need. Yes? Why do you need, so very good. So you say, why do you need a class? Class is something we call encapsulation. Have you heard this word? Encapsulation. That's a big word. It looks like a capsule. It has many benefits. One of them is this encapsulation. It means you are putting everything in one box. It's like you're making things boxy. How is it? Again, look at this car. I'm going to keep showing this. You say, well, I want several methods and several variables to be in one, like a compartment, one box for me. It's a one way to make your program component oriented. How is it that we are doing it here? Here you are saying, well, I have 5 functions and 1 variable, and I'm putting them in one data structure. This is actually a data structure or a structure. And later, my job is easier. See, this is actually very easy to read. I know it's too much code, but you say, see, this is like what we humans do. You say, well, give me an account. Well, show me its balance. Then I'm adding some money. Then you can show me my balance. I add more money. Show me the balance. I want to remove. Show me the balance. So the way we use it later, it becomes very clear and very easy to read and very easy to write. I know the concept itself takes some effort to for us to learn. Like I also, when I learned object-oriented first time, it was about 20 years ago. It took a few hours and a few days for me just to understand, right? What is this? So to understand it again is just look at the example, right? Like this example, I think is a very good example. Yes.
If we were to hover over the right account 1 dot, would it show all the methods?
Yeah. Well, if you provide some description.
Okay.
See, remove. It says, yes, the parameters. See, self, amount, remove. So the annotations are this. So these are your functions, and then there are other annotations and class. So these are the underscore ones are the built-in stuff. We don't want to get into them. but the functions that you have, you are there. Yeah. So it actually here will help you to write the program. Yes.
We can now be able to, in another Python file, import money values.
Yeah. Well, you can, if you import this name, then you can keep saying this.
Yeah, or from money values, from the file name, import from that.
I think you can, well, it's not a function, so you cannot import, you cannot say from this import. You have to say import from this file star, then it will import the class for you. It will make, believe me, like again, all the, well, you're working now with Windows or Mac or mobile apps, all of them are written in object-oriented way. Object-oriented has taken, I mean, of course, the other way of programming, which is this way, of course, this is the basic. I mean, we still have functions, but we are putting them in the shape of classes. It makes programming much easier, and then if you want to write large systems. So in your future, I think, activities in programming, if you work on large programs, 100% you will work with classes. Again, it's not hard. It just needs some learning curve to get used to it. Any other question? Here, we can have you define, see, I was just saying like this, right? You can, now you can create as many accounts you want. You can create 5 accounts, 10 accounts. You can create a list of accounts if you want. You can create even a list. You can create thousands of accounts, and each of them will have their own amount and functions. And they will have actually the copy of the functions inside themselves, because functions are inside accounts now. It's like you have a box, has everything inside. It's a very nice way to program. Yes?
In another file, if you want to use the money file, you say import the money file.
I think you want to do it. I think we did by there's this thing called you know that one, right? Set path. Have you done it? I mean, there's something involved. You have to say import. Okay, let's see. Okay, from the same folder is much easier. Test money. Okay. And I'm gonna comment all these things. Well, I'm gonna put them inside the main function. So we don't need these things, okay? Boom, boom. I'm gonna say import my part G3 refactor rename. Was it? It was import, right? Okay. Interact and yeah, finding these things. How do we import that? Put it away. What do you mean?
You have to say np equals like the entire name from the file. And then
Okay, but that's too hard, isn't that? Okay, like this. But I mean, then can't you say? Okay, you can say from that guy import star. That's not better. Then you don't need it. There we go. Okay. You can say from that name import star. Then now you can use it. And so mp dot add 40. Where was the code? Then print the value. You just call it account. Account equals that, account equals add, account get balance. There you go. It works. So it just says from that file, import everything. Well, everything, then import the function, the class.
Stars everything.
Yeah, stars everything. In almost different places of programming, star means everything, right? So you guys are much younger than me. If we had something like this, you can say dir star. That's how to see. That's the that's the command line of Windows, right? That you can use star to do many other things. Yeah. I mean, well, you search, right? You can say search for all the files. Like, yeah, if you search, for example, for files in Windows, you say star.txt, this will search for everything that finishes with txt. So star means every possibility. Any other question? Okay. Have a good day. See you later.